Okay, you've seen this shape before in our previous lesson. It has a different name right now, this tetrahedron. Originally, we were calling it a triangular pyramid. Okay, so it can be called a tetrahedron. There's also some other shapes that we're going to see right now that all fall under this title of polyhedron. Okay, another one that we see is going to be a cube. Okay, you're also going to see an octahedron, all of these triangles coming together. We have an icosahedron. Notice they have this hedron except for the cube. Always has to be different. Hedron, hedron. And the last one, the dodecahedron. Okay? These are all made up of regular polygons. Remember that regular polygons are going to be all sides congruent and all angles congruent. So here you have the tetrahedron has all equilateral triangles, the cube has all squares, the octahedron has all, the outside faces are all equilateral triangles. You've got equilateral triangles in your icosahedron and in your dodecahedron as well. Okay, the nets, since we talked about the nets, you're going to have the net of your octahedron, crazy. Even crazier is your icosahedron net. Okay, we're not going to build those, but those are what they're going to look at, which brings us into our polyhedron notes. I can get there. Okay, so we should be able to apply formulas in 3D and graph in 3 dimensions. So your polyhedron is 4 or more polygons that meet or intersect at an edge. Okay, really we're talking about for our polyhedrons, it's all your prisms and your pyramids. Those are all going to fall under your polyhedron. Your regular polyhedrons are the ones that we just saw. So even this, your rectangular prism, it's a polyhedron. You've got your triangular, or not your triangular, your rectangular pyramid, that falls under there. This is your icosahedron that we just saw before. Not polygons is your cylinder, your cone, or your sphere. So anything with curves is not going to be a polyhedron. Could go to the next slide, that would be great. Here we go. Okay, space is going to be all your points in 3D. You've got your 3D coordinate grid, which you can see over here. Very strange to look at. 3D coordinate grid is going to kind of come at you. So you're going to have an x-axis that's kind of forward. You're going to have a y-axis that goes side to side, and you're going to have a z-axis that goes up and down. Okay, and your ordered triple is going to look like x, y, and then z. Okay, so for this here, 3 is your x, y, and z. You went 3 forward, then you went 2 to the right, and you went 4 up. Okay, your x-axis is coming at you. It's jumping off of your page, forward towards you or back. Your y-axis is your left to right, and then you've got up and down also kind of off of your page coming up at you. So if we want to plot these points, I've got A, 1, 2, 4. So this one here, I'm going 1 forward, 2 to the right, and then 4 up. So my x-axis is here. I go 1 forward, I go 2 to the right, 1, 2, and then I'm going 4 up, 1, 2, 3, 4. Okay, this is that first point A. Okay, this is all in space here. It's kind of coming off of your page. For B, you're going 2 back, away from you, 3 to the right, and then 1 down. So we've got 2 back, starting at 0, 0, 1, 2, back, 3 to the right, 1, 2, 3, and then 1 down. Okay, this is where B is. It's not on the axis, it's in space. Okay. And the last thing is your distance formula. So the distance between 2 points, we really just added this. Added that other one. You've already seen this distance formula. This is on your pink formula sheet. Okay, it does not need to be memorized. So to find the distance between the 2 points in 3D, I'm just going to plug it right into the formula. D equals, I need to know which ones are my X, Y, and Z. X, Y, and Z. These can be 1s. These can be all your 2s. So I'm going to have x2, 2 minus 4 squared, plus 3 minus 0 squared, plus 0 minus 1 squared. And then I'm just simplifying. I've still got the square root. I do the parentheses first. Negative 2 squared plus 3 minus 0 is 3 plus negative 1 squared. I do all my squareds. 4 plus 9 plus 1. I end up with the square root of 14 if I add those together. Okay, and you can leave it just like this, or we can plug it into our calculator and get the square root of 14 as 3.74. Okay, so either one, that's our distance in space.